Okay, we're in chapter 7.1. We're talking about identities, and we're going to practice proving identities. First, we're going to do simplifying identities. One of the things that's tough for students is realizing that we have this huge library of relationships, in this case identities, that we can use, and it's tough to find out, hey, when do I use what when? And it takes practice. So if you're getting frustrated initially, just keep practicing. It will come. It will make sense. Just keep working at it. You'll know what identity to use at a certain time. So what we're going to do is we're going to start using, we're going to simplify these two. I have these two problems here. We're going to simplify these two problems just like if you had an algebraic expression or an arithmetic expression where you have a bunch of numbers, you use order operations to make it just kind of as simple as possible. That's kind of what we're going to do right here. We're going to use these identities here to simplify both these expressions. One of the things that you can do is you can always put everything in terms of sine and cosine if things get tough. Okay, sine and cosine. So let's take a look. So I have sine x plus cotangent x times cosine x. Again, what my goal is to make this simpler. I want to kind of combine this if you can. Now, currently I can't combine it, right? Currently I can't combine it. It's not like these are like terms. But what I can do is I can take both of these things right here and put them in terms of sines and cosines, and that's kind of what I'm going to try right now. So sine x plus cotangent x sine x is equal to sine x plus, now cotangent x is equal to cosine x over sine x, and we'll have that times cosine x here, okay? Well, that didn't make it any easier, did it? It made it harder. But you'll notice that now, instead of sine, cotangent, and cosine, I just have everything in terms of sines and cosines. So know that this equals sine of x plus cosine squared x divided by sine x. Okay? So cosine squared over sine x, that's a fraction, and I got sine x here. How do I combine two fractions? Well, I get like terms. I get like denominators. So what's the common denominator between sine x and this denominator being 1? Well, it's sine x. So I'm going to multiply this part of this expression, both numerator and denominator, by the same thing. In this case, it's sine. So if I multiply both top and bottom by sine, I get this. Sine squared divided by sine. Notice this reduces down to sine x. Okay, fine. Now that I have these two fractions that have the same denominator, I can add them, and I get sine squared of x plus cosine squared of x all over sine x. Fantastic. But what do we know sine squared of x plus cosine squared of x equals? That equals 1. So this is going to equal 1 divided by sine of x. However, can we write 1 over sine of x as something different? Yes, we can simplify all of this thing down to cosecant x. So this large expression, what I did is I kind of put everything in terms of sines and cosines. It kind of helped a little bit. Then I used the Pythagorean identity, okay, which allowed us to get this thing down to this guy, okay? Okay, let's try to take a look at another one here. Let's take a look at this one over here, secant x minus cosine x all divided by sine x. Again, I got this fraction, looks kind of tough. One thing that we can do is break it up. So I'm going to break this one up a little bit. Okay, actually put it right here. So I'm going to make this equal to secant x over sine x minus cosine x over sine x, right? Sometimes breaking it up helps. Now, secant x is the same thing as 1 over cosine. So here I'll have here 1 divided by cosine x sine x. Again, secant is 1 over cosine. 1 over cosine divided by sine turns out to be 1 over cosine x sine x. And then this is minus cosine x divided by sine x. So now I have everything in terms of cosines and sines. That's good. Let's get a common denominator so I can subtract these two guys. Common denominator is cosine x sine x. So this will equal 1 divided by cosine x sine x minus, multiply top and bottom by cosine. So cosine squared x divided by sine x, cosine x, right? Well, now I have this subtraction problem where they have the same denominators, so let's just subtract the numerators. If I subtract the numerators, then I'll get 1 minus cosine squared x divided by sine x, cosine x. Of course, 1 minus cosine squared of x is sine squared of x. So this will equal sine squared of x divided by sine x, cosine x. Now what's common on top and bottom? Well, factor of sine x. So if I eliminate the factor of sine x on top and bottom, I'll have sine x divided by cosine x, which of course, using our identity, tangent x equals sine x over cosine x, this thing just equals tangent x. Okay? So what I did is I reduced this fraction problem right here, secant x minus cosine x divided by sine x, and I did steps. I put everything in terms of sine x and cosine x, got a common denominator, used the Pythagorean identity, and reduced down to tangent x. So this is kind of one of the things that we can do. We can always put things in terms of sine x and cosine x, sometimes playing around with it that way. What I kind of liken this stuff as, anytime you're dealing with identities and trying to either simplify expressions or prove identities, I kind of think of it like a ball of yarn, and you're a cat. This is a silly example, but you're a cat with a ball of yarn, and the cat's goal is to unwind this ball of yarn. Now he doesn't know exactly how to do it, but he knows if he keeps playing around with it, batting it around, eventually it will happen. And that's kind of what you have to do here. Part of it is getting experience, working on these and practicing these extensively will allow you to get better at them. But the other part of it is you just kind of keep manipulating things around and using things that you know and changing things and using identities and substitution until it all works out. So it does take work, and it's not easy.